Module 1, Section 5, Objective 13. And this is multiplying whole numbers. So this is the actual algorithm now. So Roxy is ordering candy to restock some items at her gourmet candy store. The chocolate truffle turtles cost $3 per package, and she orders 27 packages. How much money will she spend on the chocolate truffle turtles? Write a multiplication expression that represents the total cost, estimate the total cost, then draw an area or model array to find the product. Okay, so you can see all of their stuff down here at the bottom, and they did not do the area or model array to find the product. They did it completely differently. So let me cover up what they've got, and I'll show you. Okay, so 3 packages, or $3 per package, and she orders 27. So we could add 3 27 times, or we could go 3 times 27, right? Okay, so 3 times 27. So we just wrote the multiplication expression that represents the total cost. So now we're going to estimate it. Okay, so we're going to leave 3, and this is going to round to approximately 30. So 3 times 30, 3 times 3 is 9, and add the 0 at the end. So this is approximately, so this is the estimate of $90. Okay, now we're going to draw an area model or an array to find the product. Okay, and that's what this is right here. Let me get it set up. Okay, because we only have a single digit this way, and now we're going to have 20 plus 7 across the top. Okay, when you're finding an area, you do length times width, right? So here's our length and here's our width. We're going to multiply those and get our answer. The difference is we're going to break it into place value so that we can use what we learned in this chapter or this section so far and make it easier. Okay, so we're going to go distribute. 3 times 20 is 60. And then 3 times 7 is 21. Now you add these two together, and we get 81. Okay, that's an area model. That's not necessarily the way that you're going to do them every time, but it works. Okay, here's a new problem. On the next day, Roxy needs to order cases of Mega Mania Jawbreakers that cost $12 each. How much will 26 cases of Mega Mania Jawbreakers cost? Write the multiplication expression that represents the total cost, estimate it, and then use the algorithm. Okay, oh, back up. Did we get very close? Let's look and see. Okay, $81, $90. Is that close enough? Considering we rounded 27 up to 30, it's going to make a little bit of a difference, isn't it? So yeah, I think we're close enough. Okay, now on this one, I'm going to show you the area model as well, just so you can see that, and then we'll do the algorithms on top of that. Okay, so let's rewrite it. They're going to cost $12 each, and we need 26 of them. Can you imagine adding 26 times? That would not be fun. Okay, so that's our expression. Let's estimate it. Okay, now it doesn't say how. It just says to estimate. So if we rounded 12 to 10 and we rounded 26 to 30, we'd get 300. Whoops, one more 0. There we go. If I use 10 and, oh, it's about 25, we get 250. That's quite a bit of difference when you're talking about money, right? So rounding to different places is going to make a huge difference. Okay, now let me show you the area model. Now this is going to be a little bit different this time because I need 2 rows and 2 columns. 12 is going to go out here, because I'm adding 10 and 12 to get 12. 12 and 2, 10 and 2 to get 12. And across the top, I'm going to do 20 and 6 to get 26. Okay. Now we have kind of a double distribute thing going on here. I'll show you. So 10 times 20 is 200. And 10 times 6 is 60. Kind of like a times table chart, isn't it? Okay, now in the next row, 2 times 20 is 40, and 2 times 6 is 12. Now, all of the boxes need to be added up, and you can add them up however you want to, whatever makes them easy. Okay, you could add straight down, so add the teal and then the purple. You could add the top row and then the second row. You could add these two first and then add the others. It doesn't matter, okay, because that's on the board right now. That's what I'm going to do. Okay, so we have the 200 from here. And now these two add up to give you 100. And then the 12. So 200 plus 100 is 300. So we have $312. Okay, so that's how the area model works with a two-digit number times a two-digit number. Okay, now let's do the algorithm. Let me show you how that compares. Okay, I'm going to put the 26 on top and the 12 on the bottom just because putting the bigger number on top is generally what people tend to do. It doesn't matter, but that's just kind of a habit a lot of people get into. Okay, we're going to start multiplying by the 2 right here. So the 2 is in the ones place. So we're going to do 2 times 6 and then 2 times 2. But now this 2 is actually a 20, isn't it? So it's 2 times 6 and 2 times 20, which is what we did right here. There's a 2 times 20, and there was a 2 times 6. Okay. All right, so let's see what we get. 2 times 6 is 12, right? So instead of putting the 1 down here, because we're not done, we're going to put up over the top like we're carrying, like we did with add, because it's in the tens column, so it's going to go above the number in the tens place. So now we're going to go 2 times 2. 2 times this 2 is actually a 20, right? But still 2 times 2 is 4. Add this 1 is 5. So what this is saying is 2 times 26 is 52. That's exactly right. Okay, now we're going to move over and times by the number in the tens place. So in this case, it's just a 1, so that makes it easy. But when I go 1 times 6, it's not really a 1 I'm timesing by, it's a 10. Because that 1 is in front of the 2, making it a 12. Sorry for my dog sneezing in the background. Okay, so 10 times 6 is 60. So I can't put the 6 here in the ones place because it represents a 60. It needs to move over 1 column and be put in the tens place. Okay? So 1 times 6 is 6, and it's shifted over 1 place at the bottom. Okay, now 1 times 2 is 2, and it goes in front of that. And the reason why that happens is this is 10, and this is 20. Okay, 10 times 20, 1 times 2 is 2, and then the zeros, that's 200. So it needs to be in the hundreds place, which it is if you move over 1 place. Now we're adding these. So 2 plus nothing is 2. 5 plus 6 is 11. Carry 1. And 3. So we have $312, which is exactly what we got before. Okay, what about our estimate? This seems a little off, doesn't it? Okay, now this is because we're multiplying now. If we rounded 12 to 10, we took 2 off, didn't we? So our answer is not going to be off by 2. It's going to be a repeated addition of 2 26 times. Okay, so this number is quite a bit off of this number compared to what we had. However, it's still pretty close, so I think we're still okay. Let's try another one. Actually, here's their directions. This is what I just explained on the last couple examples. Okay, so you can go back and look at this anytime you want, but I'm going to go ahead and do another example. And I'm going to get rid of their stuff so we can do it ourselves. Okay, that first problem that we did with the candy store, those are harder than these are, so I think you should be okay. And I forgot, I keep erasing and not erasing and whatever, and I apologize. So here we go. We are going to line this up, so we're going to put the longer number, in this case the 42, on the top. And the reason for that is you're going to multiply 3 times both of these. Whatever's on the bottom row is what you're going to multiply by. So if I had a 2-digit number down here, I'd have to multiply by the 3 and then by both numbers. If you have a single digit on the bottom, you only have to do it once. Okay? So here we go. 3 times the 2 is a 6. Right? Okay. Now 3 times a 4 is a 12. So it just goes next, one number in each place. And you're done. We don't have another column to move to, so we're done. 126 is the answer. Okay, now on B, again, I'm going to put the long number on the top, so 671 times 9. Okay, so 9 times 1 is 9. Now, 9 times 7 is 63. So I put the 3 down and carry the 6. Now, 9 times 6 is 54. And add this 6 is 60. And you're done. That's it. You can see how this would be ultimately harder if you don't know your times tables. So please, please, please memorize your times tables, okay? All right, F. 72 is going to go on the top, times by 4. Let me show you what I meant on the other side. What if I put a 4 on the top and a 72 on the bottom? First, other than looking really strange, now we have to multiply 2 times 4, and we get 8. And now we have a second row. 7 times 4 is 28, and we had to move over 1, and that's just a big mess that it doesn't need to be. Okay, because if I just have the double digit on the top and the single digit on the bottom, you only have to do this process once. So 4 times 2 is 8. We don't need to carry anything. We're done on that one. So 4 times 7 is 28. And you're done. Last one. 7,620 times 8. Okay, so 8 times 0 is 0. 8 times 2 is 16. So you put the 6 down and you carry the 1. Now we're going to do 8 times 6 is 48. Add the 1 is 49. Put the 4 down. Try it again. Put the 9 down. Carry the 4. Now 8 times 7 is 56. Add the 4 is 60. So our answer is 60,960. Okay, now on this page they have it all done for you already, and they have some explanation over there. but I'm going to erase that and we'll talk about it. Okay, we did one kind of like this when we were doing the candy problem because we had two numbers on the bottom. But let's go ahead and line this one up. Longer number on the top, shorter number on the bottom. There we go. So we're going to go 2 times 4 is 8. You always start with a ones place. And now 2 times 0 is 0. 2 times 8 is 16. Okay, so now I'm going to stick with the same colors on the 5. So 5 times a 4 is 20. Now remember, we're going to move it over one column. So the 0 goes there and the 2 carries. Okay, so now 5 times 0 is 0, but we have to add this 2, so it's 12. It's 2, not 12. There we go. We don't have to carry anything. 5 times 8 is 40. Okay, now we're going to add these up. We get 8, 0, 8, 1, and 4. So it's 41,808. Okay, so really important, make sure you move over 1 on that second row. Okay, let's do the next one. Okay, I can put the 18 on the top and the 75 on the bottom, or because of the commutative property, I can put the 75 on top and the 18 on the bottom. So the question you need to ask yourself is, do you want to multiply by 5 twice and then 7 twice, or 8 twice and 1 twice? Multiplying by 1 is really easy, so I'm going to choose this one. Okay, let's go ahead and do it. So we're going to do 8 times 5 is 40. Put your 0 down, carry the 4. 8 times 7 is 56. Add the 4 is 60. That worked out pretty slick. Okay, so now let's move over and do the 1. 1 times 5, and we're moving over one place, is 5. And now 1 times 7 is just 7. Now remember, we didn't carry anything. This 4 was from before, so we don't need that. It's just 7. Add these up. 0, 5, and 13. Okay, let me do the other one just to show you. So 5 times 8 is 40. Carry 4. 5 times 1 is 5. Add the 4 is 9. Okay, now you might want to erase this 4 so you don't get it confused. Okay, now I'm going to do 7 times 8 is 56. We're moving over 1. 6 goes down. Now you carry a 5. So it's a different number that we're carrying. That's why getting rid of that first one is helpful. Okay, so now 7 times 1 is 7. Add the 5 is 12. Add these up. 0, 15, 3, and 1. Same answer, so that proves that the commutative property does work even with more complicated problems. Okay, here is another method of doing multiply, and it's extremely hard to explain why it works, but it does work every time. Okay, I'm going to leave theirs there and do ours to show you. Okay, so I'm even going to draw it while you're watching so that you can see how to do it. Okay, so you see they did it taller than wider. You can do it either way you want, and I'll show you both ways here. Okay, so you're going to put numbers in it, so you need to make certain that you have space to write. Okay, so we have 294 down the side. and 86 this way. Okay, it's not exactly place value, or I would have had a 200 here and a 90 there and an 80 there, but it's close. Okay, so now we're going to draw diagonals in this way. Whoops. Let's make it actually look good. Okay, so now it's just individual multiply problems. So 2 times 8 is 16. One number in the top, one number in the bottom. Okay, there's never going to be a time when you need a third place with just two numbers. Okay, so now we're going to go 2 times 6 is 12. Good part about this method is you don't have to keep track of what column things go into. It works every time. It's just really hard to explain why it works. Okay, so 9 times 8 is 72. 9 times 6 is 54. Okay, now 4 times 8 is 32, and 4 times 6 is 24. Okay, so now we got our grid filled in. This is sometimes called the lattice, by the way. Okay, I don't know if that has two T's or one. I think it has two. Lattice. Okay, now we're going to add this way through the diagonals. I know, strange. Okay, so starting here, because that would be the ones place. So you get a 4. Now I move to the next diagonal. 4 plus 2 plus 2 is 8. Next diagonal. 2 plus 5 is 7, plus 2 is 9, plus 3 is 12. So now see, the 4 is kind of getting in the way, but that's all right. So 12, carry 1. And now the 6 is getting in the way, but we're up here now. So 1 plus 1 is 2, plus 6 is 8, plus 7 is 15, carry 1. 1 plus 1 is 2. And now you write these numbers in order. So the answer is 2, 5, 2, 8, 4. So 25,284. And just to show you, 294 times 86 over here, we're going to do the algorithm. So 6 times 4 is 24, carry 2. 9 times 6 is 54, add 2 is 56. 6 times 2 is 12, add 5 is 17. Okay, now we're going to move on to the 8. So we're not using these numbers, we're using new numbers. Move over 1. 8 times 4 is 32. 9 times 8 is 72, add 3 is 75. 8 times 2 is 16, add 7 is 23. Add straight down. We get 4, 8, 12, 5, and 2. Exactly the same thing. Okay, so it's kind of cool, but it takes up a lot of space, and once you move into algebra and stuff like that, it may not be the best thing for you to use. However, it does work. Okay? All right, we're going to have 4 this time. Didn't go quite far enough. Here we go. So 1,025 and 78. Oh, I said I'd go both ways and show you. I'll do one here in just a sec. Okay, so breaking this into, whoa, that one's way off our diagonals. All right, let's do some multiplying. So 1 and 7 is 7. So a 2-digit number, it only uses the bottom number, so it's the 0, 7. Now 0 times 7 is 0. 2 times 7 is 14. And 5 times 7 is 35. Okay, second column, we're going to times everything by 8 now. So 1 times 8 is 8, 0 times 8 is 0, 2 times 8 is 16, and 4 times 8 is 40. Okay, multiply is done. So now we're going to add on an angle, starting down here. So 0, 6 plus 4 is 10, plus 5 is 15, carry the 1. Next column, so 0 and 1 is 1, add another 1 is 2, add 4 is 6, add 3 is 9. Okay, what I like to do doing this one, instead of curving up the side like we did here, I just continue writing it straight across the bottom here, because that's going to be my answer anyway. Okay. Next one is, we didn't carry anything, so we just go ahead and add. So 8, 0, 0, and 1 is going to be 9. Next column, 0, 7, and 0 is 7. And the last column is 0, so I don't need it, right? So this is 79,950. Let's do the algorithm just to show you. 1025 times 78. 5 times 8 is 40, carry the 4. 2 times 8 is 16, add 4 is 20, carry the 2. 8 times 0 is 0, add 2 is 2. And 8 times 1 is 8. Okay, so that 8,200, you don't see it anywhere in here, do you? Yeah, so that's why it's a little different. Okay, now we're going to move over 1 on the bottom. 7 times 5 is 35. Carry 3. 7 times 2 is 14. Add 3 is 17. 7 times 0 is 0. Add 1 is 1. 7 times 1 is 7. Now we're adding. So we get 0, 5, 9, 9, 7. And it's the same answer. Okay. Personally, I like the algorithm better because it makes more sense to me. It takes up less space. I don't have to draw that grid first before I even get started. However, maybe the lattice is easier for you because you don't understand where to put the numbers when you're using the algorithm. However, I would suggest learning the algorithm before we move too far into the rest of these terms. Okay, for right now this is okay, but eventually the algorithm is going to be more useful. Okay, let's try again, or try another one. Actually, this is the area model. Okay, so you can see I put a 50 and a 7 across the top because that's 57, and 63 down the side. Okay, so 60 times 5, that's this box here because it goes this way, right? So 6 times 5 is 30, and then the 2 zeros we didn't use, so that's 3,000. Okay, now 3 times, let's go do the first column first. So 3 times 50, 3 times 5 is 15, and add the 0 that we didn't use. Okay, now the next one, we're going to move over to the 7th column. So 60 times 7, 6 times 7 is 42, and then the 0 we didn't use. And then 3 times 7 is 21. Okay, is that incredibly helpful? Maybe not. Is it easier? Maybe, maybe not. But it will give you the right answer. Okay, so add these up, and we get 3,150. And add these up, we get 441. Now add those up. So we get 3,591 as our answer. We could double check it with an algorithm and with the lattice, but this is just giving you something else to look at, a different way of doing it. Okay? Okay, this last problem we have here, I'm going to do it all three ways. Okay, so there's this way with, this is called the area model. Then I'll do the lattice and I will do the algorithm. Okay, so here we go. Because I have it set up with the 2 on this side, that means 80 goes here and 6, that's our 86. 3 across the top means this is going to be 294. Okay, so 200 times 80 is going to go in here, right? So we're going to do 2 times 8 is 16, and then 1, 2, 3 zeros. Okay, now 6 times 200 goes here. So 6 times 2 is 12, and then the 2 zeros. Okay, 80 times 90 is going to go here, right? So 8 times 9 is 72, and then 1, 2 zeros this time. Okay, 6 times 9 is 54, and just 1 zero. Last row, or last column rather, so 80 times 4 is going to go right here. So 8 times 4 is 32, and the 1 0 that we left off. And now 6 times 4 is just 24, right? Whoops. Now we need to add all 6 of those boxes together. So what's the easiest way? No idea. I'm just going to add this way, this way, this way, get my 3 answers, and add them up to get my final answer. Okay, so I'm going to line up the 1600, rewrite it right over here so I know I get it lined up right. Okay, so 0, 0, 2, 7, 1. 17,200. Same thing with this one. I want to line it up properly, so I'm rewriting. So 0, 4, 7, 7. 7,740. And this last one, add those up, we get 4, 4, and 3. Can't really do those in our head either, so I'm going to line it up over here. And remember, you're lining it up with the ones place, so that's the right column, right hand side. And adding. So straight down, 0, 0, and 4, 0, 4, and 4. And now this column here, I'm going to do 7 and 3 is 10, add 2 is 12, carry 1. 7 and 7 is 14, add the 1 is 15. So 25,284. So was it easy? It wasn't too bad. Was it quick? Definitely not. Okay, so 294 times 86. Okay, let's do this one the lattice method this time. And here's the other one right up there, so we have it compared to. I've just written the 25,284 down because that's what we're going to see if we get, right? Should match. Okay, so lattice. Should we do it this way and see? So we're lining it up the same way as the one we just did, with just a little bit of a difference, right? Okay, so 294 and 86. Okay, so 8 times 2 is 16. 8 times 9 is 72. 8 times 4 is 32. Okay, 6 times 2 is 12. 6 times 9 is 54. And 6 times 4 is 24. Okay, now we're going to add the columns. So we have a 4 from that one. This one we have 2 plus 2 is 4 plus another 4 is 8. This one we have 3 plus 2 is 5 plus 5 is 10 plus another 2 is 12. Carry the 1. This one we have 1 and 7 is 8 plus 6 is 14 plus 1 is 15. Carry 1. And 1 plus 1 is 2. 25,284. We got it. Okay, one more method, and that's the algorithm. So let me slide this over. Actually, rewrite it one more time over here, and then I'll slide it over and we'll try it again. Okay, so 294 times 86, and there we go. This is what we need to try with the algorithm this time. Okay, and the algorithm goes like this. I'm going to put the long one on the top, short one on the bottom, and multiply. Okay, so multiplying the 6 by everything. So 6 times 4 is 24, carry 2. 6 times 9 is 54, add 2 is 56. 6 times 2 is 12, add the 5 is 17. Okay, 8 times everything. And remember, we're going to slide over 1 because we're timesing by tens. It needs to start in the tens place. So 8 times 4 is 32, carry the 3. Now I'm looking at the numbers I carry that are in teal, right? That should be easy to distinguish between the two. 8 times 9 is 72. Add the 3 is 75. So you carry the 7. 8 times 2 is 16. Add the 7 is 23. So we're adding these up. We get a 4. 6 plus 2 is 8. 7 plus 5 is 12. Carry the 1. 3 plus 1 plus 1 is 5. And then the 2 just comes down. So 25,284 is exactly the same. Okay, so this method is much quicker. It takes up less space. It might be more complicated if you don't know your times tables really easily, or if you don't understand the algorithm. But much quicker, much smaller space. This one was really nice because you don't have to worry about anything other than your times tables. It's just one number times one number, and that's it. But if you don't line it up right and you don't add correctly, then you're going to be messed up there too. This one is pretty easy, again, because you're only doing a single number times a single number and keeping track of your zeros. But knowing that you have to add this way and then add this way, it gets kind of complicated, doesn't it? Okay, they will all give you the same answer, but this is the way that you need to eventually learn how to do, because that's going to be much quicker in the long run.